look up at the night sky on a clear, dark night. If you are far away from the city lights, you might see a few thousand stars. And if you are really lucky, faint, cloudy band stretching across the dark. That is the Milky Way. For a long time, we thought that was it. We thought our little island of stars was the entire universe. But I want you to imagine something for a moment. Imagine taking a grain of sand, holding it at arm's length against the sky, and looking through it at the dark, seemingly empty patches of space between the stars. For years, we thought there was absolutely nothing there. But when we actually pointed our best telescopes at that tiny speck of blackness and stared at it for days, the image that came back broke everything we thought we knew. In that single piece of sky, the size of a grain of sand, there were thousands of entire galaxies, not stars. Galaxies. When we do the math for the whole sky, we realize that there are at least 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars and countless worlds, which brings up a deeply profound question. If the universe was designed just for us, if human consciousness is the whole point of this grand stage, then why is the stage so unbelievably massive? Why would God or nature or the fundamental laws of physics bother to create 2 trillion galaxies? It feels like a massive waste of space. But I am going to show you exactly why it is not a waste at all. The vastness is not a mistake. It is a physical necessity. Stick around and subscribe to the channel if you want to figure this out with me, because the real reason the universe is so big is far more beautiful than anything we could have invented. Let us find out why. Start by getting a real feel for what we are actually talking about when we say the word galaxy. It is very easy to throw around big numbers and lose the physical reality of what they mean. Think about a single drop of water. If you look closely at that drop, it seems calm, just a tiny bead of liquid. But if you could zoom in, down to the atomic level, you would see billions upon billions of water molecules violently bouncing off each other. The calm surface is an illusion of scale. Now, flip that perspective and look up. A galaxy is like that drop of water, but on a cosmic scale. It is a swirling, unimaginably massive city of stars, gas, dust, all bound together by the relentless pull of gravity. Our home, the Milky Way, is one of these cities. It is so wide that a beam of light traveling at 300,000 kilometers per second takes 100,000 years just to cross from one side to the other. To understand why there are 2 trillion of these galaxies, you first have to understand a fundamental rule of nature. Space and time are the exact same thing. You cannot have one without the other. When you walk outside and feel the warmth of the sun on your face, you are not feeling the sun as it is right now. You are feeling the sun as it was 8 minutes ago. That is how long it took the light to travel across space to reach your skin. When you look at Sirius the brightest star in the night sky, you are seeing the light that left it over 8 years ago. You are always looking into the past. So, a telescope is not just a magnifying glass. It is a literal time machine. When astronomers point their telescopes at those tiny dark patches of sky and see galaxies, they are seeing light that has been traveling for billions of years. This brings us to the most crucial piece of the puzzle. Why is there so much space? Why so many galaxies? To answer that, we have to look at ourselves. Look at your hand. Look at the veins, the skin, the bone. You are made of complex elements. Carbon, oxygen, nitrogen, iron in your blood, calcium in your bones. Where did those elements come from? They were not there at the beginning of the universe. In the very beginning, right after everything expanded from a single point, there was only hydrogen and a little bit of helium. Just simple, basic gas. You cannot build a human being out of just hydrogen gas. You cannot build a planet like Earth out of it either. So how did we get the heavy stuff? The universe had to manufacture it. The only factories in the universe hot enough and dense enough to forge carbon and iron are the cores of stars. Gravity pulls the hydrogen gas together, crushing it until it ignites. And for millions of years, the star cooks lighter elements into heavier ones. But that is still not enough. The elements are trapped inside the star. For them to become planets and people, the star has to die in a massive explosion called a supernova, scattering those heavy elements across space to eventually form new solar systems. This entire process, the birth, life, explosive death of generations of stars, takes time, an enormous amount of time, billions and billions of years. And here is the beautiful, undeniable trick of physics. The universe has been expanding ever since it began. It is stretching out. Therefore, for the universe to be old enough to have had the time to cook the carbon in your cells and the iron in your blood, it has been expanding for nearly 14 billion years. A universe that is 14 billion years old must, by the laws of physics, be tens of billions of light years across. The vastness is not a waste. The vastness is a direct measurement of the time required to create you. But this raises an even deeper mystery. If the vastness is required for us to exist, why did the expansion happen exactly the way it did? Why didn't it collapse back in on itself or tear itself apart before stars could even form? That is where things start to get truly strange. Let us look a little closer at that expansion. I want you to imagine you are standing in your backyard, holding a baseball. You throw it straight up into the air. What happens? Gravity pulls on it, slows it down, and eventually it falls back into your hand. Now, imagine you have a cannon and you fire that ball straight up, up. It goes much higher, but gravity is relentless, and eventually it comes crashing back down. But if you could strap a rocket to that ball and blast it upward at over 11 kilometers per second, it would break free. It would overcome the downward pull of the Earth and drift into the blackness of space forever. The birth of the universe was a lot like that throw. In the very beginning, all the matter and energy was thrown outward with unimaginable force. But at the exact same moment, all the mass in the universe was pulling back inward through the force of gravity. A cosmic tug of war began immediately. If the initial outward push had been just a tiny bit weaker, gravity would have won the war early on. The universe would have expanded for a little while, slowed down, stopped, and collapsed back in on itself in a fiery crunch. There would be no time for stars to form, no time to cook carbon, no time for us. On the other hand, if the initial push had been just a fraction of a fraction stronger, the matter would have flown apart so rapidly that gravity could never pull the hydrogen gas together. There would be no clumps of gas. No stars would ever ignite. The universe would just be a rapidly expanding, dark, empty freezer. But it did not do either of those things. The universe expanded at exactly the right rate to allow stars to form, to allow 2 trillion galaxies to clump together, to remain stable for 14 billion years. When I say exactly the right rate, I am not talking about getting it right within a few percentage points. The precision required is so staggering that it is hard for the human brain to comprehend. It is like taking a single dart, throwing it from across the entire observable universe, and hitting a target the size of a single atom. That is how finely balanced the initial expansion had to be. And it is not just the expansion rate. As we physicists dug deeper, we found that this mysterious balancing act is everywhere. We found that nature has a set of hidden dials, numbers that dictate how strong gravity is, how heavy an electron is, how tightly atoms are bound together. Think of an old-fashioned analog radio. To find a clear station, to turn the dial incredibly carefully. If you miss it by a millimeter, all you hear is static. The fundamental laws of physics are just like that radio. Take the strong nuclear force, the glue that holds the center of atoms together. If that force was just 2% stronger, the universe would have burned through all its hydrogen almost immediately. There would be no water, no fuel for long-lived stars like our sun. If it was just 5% weaker, atoms could not hold together at all. There would be nothing but loose particles flying around. No carbon, no biology, no you. Everywhere we look, from the massive scale of 2 trillion galaxies down to the microscopic scale of a single electron, the dials are tuned perfectly for life to eventually emerge. So we are left staring at this immense ancient cosmos. We have to ask the obvious question. How did it get so obvious question? How is it that out of all the infinite possibilities, the universe was born with the exact razor-thin parameters required to create observers? This is where physics starts to feel like philosophy. We have the data, we have the measurements, but the numbers feel too perfect. And when things look too perfect in science, it usually means we are missing a much deeper, much stranger truth. This perfection leads us directly into a trap, a paradox that forces us to question the very nature of reality itself. Let me tell you how this realization feels to a physicist, because it brings us face to face with the ultimate paradox of our existence. Imagine you are blindfolded and placed in front of a thick brick wall. A firing squad of 50 expert marksmen lines up, raises their rifles, aims directly at you. You hear the countdown. You hear the deafening roar of 50 guns firing at exactly the same time, but you do not feel anything. You open your eyes. You are completely unharmed. You look at the brick wall behind you, and you see a perfect outline of your body drawn in bullet holes. Every single bullet missed you by a fraction of an inch. Now, how do you react to that? You could say, well, if they had not missed, I would be dead. I would not be here to think about it. Since I am standing here thinking about it, I should not be surprised that they missed. But that is a completely absurd way to think. You would be overwhelmingly surprised. You would demand to know how it happened. Was the firing squad bribed? Was it a trick? Were the guns rigged? You would know with absolute certainty that 50 expert marksmen do not miss their target by pure chance. This is exactly the situation we find ourselves in when we look at the fundamental constants of the universe. We are standing in front of the wall, perfectly outlined by the laws of physics, completely unharmed. We look at the strength of gravity, the mass of the electron, the expansion rate of space. We realize that 50 rifles just missed us by a millimeter. If any one of those numbers were slightly different, we would not exist. Brings us to what scientists call the anthropic principle. The basic idea is that the universe must be the way it is, because if it were any different, there would be no observers around to ask the question. We can only observe a universe that is capable of creating observers. While that is logically true, it is completely unsatisfying. It is just like the guy in front of the firing squad saying he should not be surprised he is alive. It is a true statement, but it does not explain the mechanism. It does not explain why the universe was dialed in so perfectly in the first place. So, we are forced to look at the real possibilities, and we are left with a very uncomfortable set of options. Op 1 is that the dials were set on purpose. A grand designer, a creator, tuned the universe specifically so that you and I could be here talking about it. For a lot of people, this is a beautiful and comforting thought. But in science, we cannot simply throw our hands in the air and say, it is magic or divine intervention. Our job is to keep pulling the thread, to keep asking how the machinery actually works. Option 2 is that there is a deeper law of physics that we just have not discovered yet. A single elegant mathematical equation that explains why these numbers absolutely must be what they are. Think about a circle. The distance around a circle divided by the distance across it is always the exact same number, pi. It cannot be anything else. It is a geometric necessity. Perhaps the mass of a proton or the strength of gravity are like that. Perhaps they cannot be anything else. We just do not have the complete mathematical picture yet to understand why. But then there is option 3. This is where the paradox forces us to consider something terrifying and spectacular. Think about a lottery. The odds of you buying one single ticket and winning the grand prize are essentially 0. It is a statistical impossibility. But what if someone buys 1 trillion tickets? What if someone buys every single combination of numbers? Suddenly, it is no longer a miracle that they won. It is an absolute mathematical guarantee. What if nature bought 1 trillion lottery tickets? What if our universe, with its perfect laws, 14 billion years of history, and its 2 trillion galaxies, is not the only universe out there? I want you to walk into your kitchen and put a pot of water on the stove. Turn the heat all the way up. At first, nothing happens. The water is perfectly still. But as it absorbs the heat, you start to see tiny, energetic bubbles forming at the very bottom. They expand, they rise, eventually they pop at the surface. Now imagine that the water in that pot is not water at all. Imagine it is the fundamental fabric of space itself. The heat underneath the pot is an immense repulsive energy, driving everything to expand at a violent, unimaginable speed. In the 1980s, physicists studying the Big Bang realized something profoundly disturbing. The initial expansion of space did not just happen once and then stop. The mathematics tell us that this rapid stretching and a process we call inflation is eternal. It is happening everywhere, all the time, forever, into the past and forever into the future. But just like that boiling pot of water on your stove, little pockets of space occasionally cool down. They lose their explosive energy and stop expanding so violently. When one of these pockets cools, a bubble forms. The rapid expansion halts inside this bubble, and that leftover energy transforms in form into particles, into light, into matter. I want you to listen to me very carefully right now, because this is the exact moment where your brain is going to try to reject what I am telling you. Our entire observable universe, every single star you have ever seen in the night sky, every planet we have discovered, all 14 billion years of cosmic history, and all 2 trillion galaxies we talked about earlier, is just the inside of one of those microscopic bubbles. We are sitting right now inside a single bubble in a boiling cosmic ocean. And outside our bubble, that eternal violent expansion continues, creating more bubbles. Billions of them, trillions of them, an infinite number of separate, completely isolated universes being born every single second. We call this the multiverse. And here is the trick that makes it so terrifying. Space between our bubble and the next bubble is expanding far faster than the speed of light. That means light from another universe can never, ever reach us. You could fly in a spaceship for 1 trillion years, and you would never hit the edge of our bubble, though, let alone cross over into the next one. We are permanently sealed inside our own pocket of reality. Remember those 50 expert marksmen aiming at you? Remember how we demanded to know how they all missed? Well, if nature is a boiling pot, endlessly creating an infinite number of bubbles, then every single bubble gets a totally different set of laws. The physics dials are spun at random every time a new universe is born. In bubble number 1, gravity is just a little too strong. The universe is born, but it immediately crushes itself back down into a microscopic black hole, dead. In bubble number 2, the strong nuclear force is too weak. Protons and neutrons cannot stick together. It is a lifeless, freezing soup of lonely particles. Dead. Bubble after bubble, universe after universe, is born completely sterile. Billions upon billions of entire cosmos are completely empty, devoid of chemistry, devoid of light, devoid of absolutely anyone to look up and ask why they exist. But if you roll the cosmic dice an infinite number of times, eventually, by pure mathematical necessity, you will get a bubble where the dials align perfectly. Gravity is just right. Electrons have the exact right mass. Stars can ignite. Carbon can cook in their cores. We are not living in a universe that was magically tuned just for us. We are simply the winners of a cosmic lottery that printed an infinite number of tickets. We only exist, and we can only ever exist, inside the specific bubble where the temperature and the pressure allowed us to evolve. When I first really understood this, it shook me, because it means the sheer scale of reality is so far beyond human comprehension that our massive 2 trillion galaxy home is literally less than a grain of sand on an endless beach. God, or nature, did not waste space. The infinite vastness of dead universes out there is the exact physical price that had to be paid to get the machinery right just once. But do not get too comfortable. Because if this boiling ocean of universes is real, it creates a new terrible problem. A problem so unsettling that it forces us to question our own minds. We have traded one mystery for a much darker one. I want you to think about a simple deck of playing cards. Imagine you shuffle it. It is a complete mess. You shuffle it again, and it is still a mess. The chances of shuffling a deck and having it land in perfect order, with all the hearts, spades, diamonds, and clubs lined up exactly right, from ace to king, is practically zero. You could sit there, shuffling cards every single second for the entire 14 billion year history of our universe, and you would almost certainly never see it happen. But what if you had an infinite amount of time? If you sit in a room shuffling that deck forever, eventually, pure statistics guarantees that the cards will land in perfect, pristine order. It is not magic, it is just the brutal, capable math of infinity. Given infinite time, anything that can happen will happen. Now, I want you to apply this rule to that infinite, boiling ocean of the multiverse we just talked about. We established that most of the universes out there are dead. They are cold, completely empty voids where the dials of physics were tuned all wrong. But in physics, we know that empty space is never truly empty. Even in a dead universe, at the subatomic level, the fabric of space is jittery. Particles constantly pop into existence out of absolute nowhere, exist for a fraction of a second, and then vanish. We call these quantum fluctuations. It sounds like science fiction, but we can actually measure this happening in the laboratory right now. So you have these completely dead, empty universes sitting there for an infinite amount of time. Just like shuffling the deck of cards, these random quantum fluctuations are happening endlessly. Most of the time, a couple of particles pop up and immediately disappear. But given infinite time, eventually those random particles will accidentally arrange themselves into something more complex. If you wait long enough in a dead universe, quantum particles will spontaneously assemble into a rock. Wait longer. They will spontaneously assemble into a chair. And this brings us to the hard truth, the terrifying statistical nightmare that keeps physicists awake at night. What does it take to make you? Your entire consciousness, your personality, your memories, and your experience of reading this exact sentence right now. All of it lives entirely inside your brain. Your brain is nothing more than a highly specific, complex arrangement of atoms. Now, I want you to weigh two scenarios. Scenario 1. A universe begins with a massive explosion. It expands perfectly for 14 billion years. It creates 2 trillion galaxies. It forges heavy elements inside the cores of dying stars. It forms a solar system, a planet, sustains billions of years of biological evolution just to produce the exact arrangement of atoms in your brain today. Scenario 2. In a cold, dead, empty universe, an infinite amount of time passes. Eventually, random quantum particles accidentally pop together for a single second to form a fully functioning human brain floating in the void. Which one is easier? Which one is mathematically more likely? We call this the Boltzmann brain paradox. And the math is terrifyingly clear. It is infinitely more likely for a lone brain to spontaneously pop into existence in a void, hallucinate a life for a single second, and then dissolve back into nothing, than it is for our massive 2 trillion